Hello everyone, this is the fifth lecture of C++ with DSA playlist. In this video lecture, we are going to discuss about the data types in C++. So, in our last video, we are left with one more rule. So, our last rule for writing variables is, fifth rule for writing variables is, the variable name should not be any keyword of C++. Like in C language, we have 32 keywords, and in C++ language, we have 95 keywords. And for that, let us first again open our the C++ IDE. Now pressing Ctrl N, and if we will see that if keywords can be used as variable names or not. So for that, again, I am writing that similar code, that is hash include iostream, then using namespace std, then declaring again my main function, which is int main, and then I am writing int. Let us suppose we have taken using as our key. Using is the keyword value of C++ language. So I have written using is equals to 10, and then I am going to print this keyword value, which is using, then endl. Now if I will print this again, I am going to save this by name variable.cpp, and now it is showing me an error, expected unqualified ID before using, expected primary expression using expression before using. So using, I cannot use using as my variable name because it is a keyword. So this was the last rule for declaring the variables, which was left in our last lecture. Now let us move towards our today's topic, which is data types. So in C++ language, we have data types of two types. One is called as primitive data types. Another is called as derived data types. Right? In primitive, we have int, char, float, double, right, long. So these are the primitive data types. Now here we have derived data types. Derived data types like arrays. Next is pointers. Next is functions. Next is structures. So these are called the derived data types. In this lecture, we are going to see about this primitive data types. What are these primitive data types? And in our further lectures, we are going to cover our derived data types like arrays, pointers, functions, and structures. So now let us discuss about these primitive data types one by one. So for that, I need to open my IDE. So I'm opening the C++, again pressing Ctrl N for new window. And here I'm writing that code, which is hash include iostream, then using namespace std, then declaring my main function, which is int main, and in here I am writing int a is equals to 10, and then I am printing this as cout a endl. So what happened in the memory? If I'll run this, let me show you by running this, and here I will write datatype.cpp, and it is showing me 0 error and 10 is printed on my console. So what is the logic behind it? Let us see that. We have written int a is equals to 10 in our code. So what is this int? This int is the data type. Means what type of data is going to store in this container. This container is our memory, right? Integer data type generally use 4 bytes of memory. It depends on compiler to compiler. If your compiler is a 64-bit, then it will use 4 bytes. Means 8 fours are 32-bit. And if you are using any 32-bit compiler, then it will use 2-byte memories. Means 8 to the 16 bits. Right. So this is not mandatory that it will always occupy 4 bytes memory. It is depend upon compiler to compiler. So this int is our data type, means what type of data is going to store in our memory. So we have declared this is our memory block, and we have assigned a variable name a to this memory block, and then we have assigned a value, that what value should go and store in this block, which is 10. So 10 should go and store in this block, and the name of this block is a. Now if I want to print this, what I will do, I will write this statement, which is cout a. Means I need to print the whatever thing is present in that container a, that I want to print that on my console. So for that I have written this statement cout a, and then this endl for next line. Right. Similarly, I can write. Similarly, my other primitive data type is char. So for char, I have declared my variable name as ch, and in char we generally write single variables in inverted commas, like a I want to store in this char ch variable. Now I want to print this a on my console. So what I will do, I will again press F11. It is showing me 0 error. Then a is printed on my console. Right. Similarly, for float value, what I need to do is I need to just write float, and then I am going to give my variable name as f1, and I will store decimal values in it. So what decimal values I can store? 12.04, let's suppose. Right, now I need to print this 12.04 on my console. So for that I will again press F11. Now you can see that 12.04 value is printed on my console. Now so far we have discussed about int, char and float. Now we will discuss about double and long. So double data type we use it for writing float values. The float values which are quite big in size, that big value cannot be stored in this float value. So we write this double as our data type, and long we use with int. If we want to store big integer values, then we use this long int. Other than this, we have two types of values, like signed values or unsigned values. In examination, it is asked that what is the difference between signed and unsigned. So signed values, we use both negative and positive values. We take both negative and positive values, and in unsigned values we use only positive values. We can store only positive values, and here we can store both negative and positive values in our memory. Right, so this is the basic difference between signed and unsigned. Now let us move towards the another concept, which is typecasting. What is data type of a variable, right? Now let us take one example by saying in our IDE, if I have written uh, int ch is equals to a or capital A, and then I need to print this ch value on my console. Oh, sorry, for printing I use cout ch then enter. Now if I will print this value, it will show me, let's see what it will show me. It has shown me 65. Why? It should show me this a value because in my ch variable a value is stored. So here typecasting has occurred. Means what? In my ch variable I have stored this character value, and this character value is having some ASCII value. So what ASCII value this character capital A is having? It is print on my console, which is 65. So 65 is printed on my console. So for this, you can check the ASCII values of other variables. Like for small a, it will show 97. You can see it has shown as 97. For dollar, let us see what it will show. It has shown me 36. That 36 ASCII value is assigned to this dollar value, this dollar character. So here typecasting has occurred. Means what I am storing in the ch variable, I am storing these characters. But these character values are converted into this int data type. Means what ASCII value is given to that is assigned to that character. That ASCII value is printed on my console. Now if I will do the same thing with char, then this I have written char a is equals to, let's suppose I want to print that small a value. Char a is equals to 97. I know that 97 is small a character. Now I am going to print this cout a, then end. This a is my variable name, so for not getting confused, I will write Rahul over here. Right now, if I'll press this F11, whatever it is showing me. Oh, sorry, I have forgot this semicolon. So this semicolon is also very important. What this semicolon does, like in English, we use full stop when after completing one statement. So in programming, in case of this C++ programming, we use this semicolon if we want to end any line, end any statement. Right now, if I'll press F11, it is showing me A as my output because A character is assigned to this 97 ASCII value. Right, so this is called typecasting. Means I am storing this int value in this char variable, but what it is showing me, that what ASCII value is assigned to that character value, that it is going to show me on my console. Right, so this was all about the data types. I hope you have understood what data types we have. And we have discussed about primitive data types in this lecture. And for derived data types like arrays, pointers, functions, and structures, we will discuss in our further lectures. So pattern problems are very important. It is asked in our placements. So we will see them. We'll begin from the basic patterns, and then we will go towards advanced patterns. So for that, we need to understand the concept of loops. So in our next lecture, we are going to understand the concept of loops. In C++, we basically have three loops like for loop, while loop, do while loop. Right. So we'll discuss these in detail in our next lecture. So thanks for watching and stay tuned. Thank you.